Welcome. With great power comes great responsibility. Those are the words of Uncle Ben to Peter Parker when Peter Parker first became Spider-Man, and they shaped his life and the way he became a hero afterwards. That was just a comic book, but as our AI solutions become more and more powerful and affect the societies that we live in, I think it makes sense to remember those words from Uncle Ben. With great power comes great responsibility. And I think we all have a responsibility to make sure that the AI solutions that we create are fair and biased to our users and the communities that we live in. My name is Fredrik Nygren. I'm the Solutions Engineering Manager for NetApp in Sweden. And in this session, I will talk to you about what the right data fabric and the right data platform can do to help you when you get into a situation where, despite your best intentions, your AI solution turned out to be biased. So introductions first. NetApp, who are we? Well, NetApp is a data management company that provides software and hardware solutions to our customers to help them and empower them to change the world with data. Well, that's a big and bold statement, right? Changing the entire world with data. But as it turns out, the world is actually changing all around us as we speak. And data is a driving factor and a big outcome out of those changes. So the big data explosion that we have been talking about for the last 20 years, it's still happening right now. So what are some of the changes that are happening that affect us and affect the data amounts and the data explosion and potential AI opportunities? Well, there are three big meta trends in the world right now. This is the first one, urbanization. We stop being farmers and we move in from the countryside into cities. Generates huge amounts of data and AI opportunities as well. Somebody needs to keep track of where all these people live, where to build new buildings, where to build parks, how to plan our public transport, our parking. There is opportunities for IoT and video surveillance and security. And we all remember the hype since the last couple of years around smart cities. This is the second big meta trend, globalization. We can order goods and services from anywhere in the world and get them shipped to our doorstep here in Sweden, for instance. And all organizations right now have to face the fact that they have a global competition and they live in a global marketplace. This also generates huge amounts of data and has a huge potential for AI to find the best, most cost-efficient workforce and the most cost-efficient production facilities, and to find the optimal route to ship goods from across the globe to my doorstep here in Sweden. Huge amounts of data, huge opportunities for AI, but this isn't where the big data explosion is coming from either. It's this, digitization, digital transformation. Every organization needs an app these days, right? So why are organizations doing this? Why is this driving data? Why is data actually a driving force behind this trend? Well, it turns out the more you know about your end customers, each specific individual, the better you can tailor your services to each individual, and the better you can plan and forecast how to build new products and how to optimize your operations. So all organizations are looking at how digital transformation can help them be more successful. This generates huge amounts of data. It has huge opportunities for AI, and it will probably change everything about the societies that we live in today. So data. We at NetApp, we help our customers build data fabrics. Data fabrics is a way to make sure that the right data and the right applications are in the right place at the right time. So today, we no longer have our data locked away in a server or a computer center somewhere. Instead, we use the public cloud for some services. We maybe build a new private cloud for some new applications that we develop. And we still have those legacy applications and those big monoliths somewhere in our data centers. Finding the right data at the right time when you need to train your AI can be hard. But with a data fabric, you can always access your data wherever you need it at any given time. Data fabrics. So on that earlier slide, where I say that NetApp wants to empower customers to change the world with data, it doesn't really say so on that slide, but I always assume that we want to change the world to be a better place, not a worse place. We want to use AI for things like planning public transport. If all of these people are walking from one place to another, that might be a good place to have a bus route. Instead of using that data and this video surveillance to keep track of our citizens and make sure that we know where each and every specific individual is at any given time. Use AI for good. So AI, what is artificial intelligence? Well, I like to think about it like this. So if we look at a basic recipe for AI, The first ingredient is data. It can be any type of data. It can be images, it can be video, it can be audio, it can be chats from a chatbot, it can be email, it can be text, it can be IoT data. Any type of data. And the more data, the better. The more data you have, the more accurate your AI will be. So see data as the source code for your AI. And then you take this data and you run it through an algorithm or a framework. These are some of the common ones, but there are a multitude of frameworks out there. And to run all of this and do all of these calculations, you need a lot of compute power. So you either run this on a big CPU farm, a big server farm, or you run it on GPUs, and probably multiple GPUs as well. On premises, in an appliance like this, or in one of the public clouds. So data, algorithms, running on compute, generates prediction machines. So once you have a trained neural network, a trained AI model, you can present new data to that model, and based on the data you train the model with, you get a prediction. This is a man or a woman, or a dog or a cat, or a car. So where can this go wrong? I'd like to give you some examples of where the intentions were good, but the outcome was less good. So Apple Card. Apple Card was launched in 2019. And it was meant to be a very transparent and non-discriminatory credit card. So there were no people involved in the equation. Instead, there was an AI determining what your credit limit should be. And you could order this from your phone and you get your credit card. All of this was excellent. Everybody loved it until this happened. So David Heinemeier Hansson, he's the creator of Ruby on Rails. He's a New York Times bestselling author. He's kind of a big deal on Twitter. And when he says that your credit card is sexist, then you should listen and try to figure out what happened. So in this case, David and his wife, they applied for credit cards, both of them. And David's credit limit was 20 times higher despite filing joint tax returns and living together. So what happened here? Where did it go wrong? Did Apple add men and women as data points to say that men should have a higher credit limit than women? Obviously not. So what happened was instead that AI is really good at finding categories and grouping data sets together. So the AI found that some individuals, they spent money on cars and computers and TVs and big ticket items. And on average, those individuals also earned more money. And of course, they should have a higher credit limit according to the AI. Because there was another group of individuals that did the day-to-day shopping, groceries, clothes, and on average, they had lower salaries, lower income. And they should have a lower credit limit according to the AI. And it just so happens that in the big spender group, it was mostly men, and in the day-to-day shopping group, it was mostly women. And that's how this bias came about, without Apple even adding men or women as data points. If they had done that, they could have actually tested for this. And my guess is that they added it since and has this as a test case. If a woman or a man applies for a credit card, should the credit limit differ based on that? So proxy bias, it's really, really easy to get proxy bias into your data set, even though your intentions were good. And Apple has since fixed this, so they took care of it. And I'll get back to some ways that the right data fabric can help you speed up that process. Two other examples. So Amazon created this recruiting AI. And the idea was that based on all of the resumes that they had been sent before and the data point, which of these resumes did we actually hire and how were their careers within Amazon later? They set about creating an AI that could take a new resume and determine if this was a good or a bad candidate for Amazon. And it turned out that this AI hated hiring women. It really preferred hiring men. So why was that? Well, the data set that they used had mostly male resumes in it. And the managers and those with successful careers within Amazon historically had been men. And the AI determined that this was the best path forward. Keep hiring men, it seems to be good for you. Obviously wrong and something that needs to be fixed. Another example is this. In the US criminal justice system, there was an attempt to create something called a recidivism score. So if you were found guilty of a crime, they wanted to give you a recidivism score to see how likely were you to be a repeat offender. How likely were you to fall back into a life of crime after your prison sentence? And based on that recidivism score, they could determine if you needed to have a long prison sentence, keep you out of the community for a long time, or shorter prison sentence because you weren't likely to fall back into crime after your sentence. And the data they used to train this was, well, what does a prison population look like right now? The prisoners that we have had, which of those fell back into life of crime afterwards? And again, with proxy bias and the data set that they used, it turned out that this recidivism score was biased against people of color. So if you were found guilty of a crime and you were a person of color, you were more likely to get a long prison sentence than if you were somebody who, for instance, looked like me. Obviously wrong and something that needed to be fixed, because we wanted to have a fair judgment. That was the whole point of the recidivism score. We didn't want a recidivism score that was already biased based on the data that we sent in. So when we use data, we need to look at the historical data that we sent in, and we need to clean up these things that could cause bias. Even if it's not by intention, it could just be proxy bias. And when this happens, we need to be able to go back and see what went wrong and how can we clean this up. So how would we fix this? If we find out that we have bias in our AI, how can we go back and clean that up and make sure that our AI model and our AI solutions are fair and unbiased again? Well, if data is the source code of your AI, it helps to treat your data as you would treat source code. So what do developers do with source code? Well, first of all, they put their source code into a big source repository. And I suggest that is the way you should look at your unified data lake. Because it's possible to build point solutions for different data sets, sitting in different databases, going back to previous versions. But if you build a holistic AI model based on multiple data sets and multiple data sources, you really need to keep all your data together and have the same capabilities regardless of your data type. So a unified data lake for all types of data that you need to train your AI models and to do your analytics. And when you build that unified data lake, it helps to build it in a way that spans across your own private data center and the public clouds. And I will come back to why that is important. And build your data lake in an open fashion so that you can use all of your data with different types of frameworks at the same time. Some of these current frameworks and some of the future frameworks that are coming out. So some capabilities that you should look for in a unified data lake. The first one is this, version-controlled datasets. So just like somebody would write source code and commit it to their source code repository when they have a known good state, so that they can always go back to a previous version of the code, and if they find a bug, they can find when that bug was introduced. When you find bias, you can find out when that bias was introduced. Because your dataset is going to be evolving. Looking at this Swedish age distribution dataset, that has also changed over time. So if I train an AI model on my dataset in 2012, and I find out in 2018 that I have a bias against the age group 70 to 79 years, you can see here that that dataset has changed a lot over those years. And I need to go back to the dataset the way it looked in 2012 to be able to track down where I introduced bias into my AI model. And if you base an AI model that will set credit limits for your credit card, you're going to base that off of buying patterns, and those happen all the time as well. There are always transactions going on. A medical AI, there are always new patients coming along, new treatments. Your dataset will always be evolving. So make sure that you can version control the dataset that you use to train your AI model today, and tomorrow, and in the future. The way we do it in the NetApp data fabric is using something called snapshots. So instead of keeping old copies of data, we make sure that you can always access the data the way it looked at any given time. We do that using pointers to data blocks. So when data changes, we write data in new places in the data lake, and we update our pointers to point to the data the way it looks like right now. But we also keep old pointers to old data blocks. So when you have a version 4 here, for instance, you can look at the pointers the way they looked when you took a snapshot of version 4. And that is the data set that you can go back and retrain your AI model on. And this is the way it would look like in a Jupyter notebook. So very simple code, just create a snapshot before you do your training. And then you keep that snapshot tied to your AI model because that is the source code for your AI. So let's say that you find out that your AI is biased. You need to fix it quickly. before it gets into the news, or maybe it's already in the news. Instead of just going down one path and having one data scientist try to track down your AI, you might want, or your bias, you might want to have multiple teams looking at your data in multiple different ways, trying to figure out where the bias was introduced and how to get rid of it. The way we do that is that we can use the snapshots of those previous datasets and create virtual forks of your datasets, virtual clones of your dataset. So without copying any data, just updating pointers and giving data scientists new views into your data, each data scientist can actually have their own private copy of your entire multi-petabyte dataset, where they can add data. So for instance, add the female population to my dataset here, or you can clean up data, remove data, slice and dice it in any way you want. You might want to look at that female population from 2014 and where did they live? Oh, no surprise, they lived in the big cities, Stockholm, Gothenburg, and Malmö. Or you might want to add the Swedish education level to see who had a a university degree, for instance, and how does that look like for a 43-year-old Swedish man. So version control datasets and being able to fork those datasets. You can work on multiple different datasets in parallel, multiple different ways of looking at the same data in parallel. Those are the ways to quickly track down bias and find out when it was introduced and then what to do about it. So you remember my recipe for AI: data, frameworks, and compute. Well, if you have to find bias and you have to train new models in multiple different ways in parallel, you need a huge amount of compute power as well. And in your own private cloud or in your own data center, you might have enough compute power to do your day-to-day training, your prototyping, your development. But when something happens and you need a sudden burst of more training and you need to prototype more models quickly, you might want to look at the public cloud for that compute power instead of buying more servers to take care of that temporary workload. But with the right data fabric, you can stretch your data across your own private data center to sit right next to these public clouds, and then have your data scientists fork that data and use different tools in different public clouds to look at their own private copies of this multi-petabyte data lake. Really powerful. And to be honest, some of the new frameworks and some of the new AI tools only come out in the public cloud. It takes ages before you can deploy them in your own data center. And they're ready as services in the public clouds right now. So a quick way to retrain your models and find new ways of looking at your data is accessible in these public clouds right now. So back to NetApp. Well, we built our own data fabric, our own data lake. We did that to keep track of telemetry data from all of our customers. So all the NetApp systems that we have sold to customers all across the globe, they send telemetry data and IoT metrics back to our data lake, so that we can see which products work better than others, how are our products used, did a hard drive break, do we need to ship something and open up a support case, for instance. So in our case, our edge here, our ingest point, that is the actual data storage system that sits out in a customer site. And our core data center, that is where we do our analytics, our training, and our development. This is where we do most of our AI work. But we also connect our data to the public clouds to take care of that cloud burst and to use new tools and rapidly prototype new models. So having a data fabric that spans across the edge to the core to the cloud has been really useful for us. So for instance, we have reduced the pipeline for introducing a new product into our data lake. When we release a new product, we want those metrics to sit in our data lake. That used to take us 6 months. We're down to a couple of weeks now. And that type of speed up is really important for us who want to release new products quickly. So edge to the core to the cloud. And having a data fabric that spans across all of this with the capabilities to have version control datasets, forking datasets, and in an open fashion so you can use all of the current and future frameworks. That is what you should look for in your future data lake. So the only question that remains really is this: how will you change the world with your data? And if you, as I hope you do, want to change the world to be a better place, do you have the right data platform and the right data fabric to help you do that? It's been a pleasure to have this session. I hope you enjoyed it. We're available for questions, and please look at our demo as well, where we will show you some of the technology that sits behind our data lake. Thank you.